Okay, this is Geometry, Chapter 1, Section 5, Exploring Angle Pairs. Um, so they give us a whole bunch of definitions about types of angles. The first thing they give us is adjacent angles, and they say that adjacent angles are two coplanar angles with a common side, common vertex, and no common interior points. I want to focus on the common interior points, but when we think of adjacent angles, here's an example of an adjacent angle. Actually, these are rays. So remember we said that an angle, they share a common vertex. So this is the common vertex that they share. Let's call this angle 1. And let's call this angle 2. Another thing that they share actually is this ray. They share this ray. Share the ray. This is an example of adjacent angles. Okay? They share this ray. So angle 1 would be this angle here to the left. And this ray in the middle is shared by both angle 1 and this angle over here to the right by angle 2. So they share a ray, they share a common vertex, they're side by side with each other. That's why they have to share a common ray. If they're not side by side, then they're not adjacent. The book gives another example of adjacent angles. Again, they share a ray in the middle. It's always in the middle because you can't really share any others. It's angle 3, angle 4, and then their common vertex also over here. They both share this guy right here. They both share the ray in the middle, and they're side by side. These are adjacent angles. With the whole they don't have share a common interior point. So if we have a point here in the interior, and a point here in the interior, this point is only inside angle 3, this point is only inside angle 4. So what they mean by not sharing a common interior point is that there isn't a point that they both share at the same time. It would have to be somewhere like along here. And the ray doesn't count as an interior point because it's the thing that separates the two angles. So it's not possible for them to share a common interior point. But I'm not going to have you really worry about common interior points. Vertical angles. And vertical angles are two angles whose sides are opposite rays. Vertical angles whose sides are opposite rays. So let's look at this. How would I want to do this? Sides are opposite rays. Okay. Let's do that. Let's do that. Let's see if that works. Yep. So angle 1 and angle 2. So angle 1 and angle 2 are vertical angles. And then we'll have angle 3 and 4. Angle 3 and angle 4 are vertical angles. Okay, so the book says vertical angles are angles whose sides are opposite rays. So I'm just going to say VERT for vertical. Angles are angles whose sides are opposite rays. Okay. So what does that mean? So remember we said that an opposite ray is a ray that forms a straight line, right? And they go in different directions. They go in opposite directions. They have to be on the same line. So there's going to be an intersection. It's going to look like usually like an X. Here's the common point that they all share in the middle. If we look at the blue line, these guys are opposite rays. They go this way and they go that way. If we look at the red line, they're also opposite rays. They go this way and they go that way. They go in opposite directions. And notice that those two lines form opposite rays, and they also are at the same time the sides of all of these angles. These pair of opposite rays that form this X, this crisscross, also form all the sides of the angles. Both sides of angle 3, angle 1, angle 2, and angle 4. They're all have a pair of opposite rays, therefore they're vertical angles. I like to sort of think about them like this. You're going to form some type of crisscross, some type of X-like figure, and angle 1, or these guys are going to be directly across from each other, and these guys are going to be directly across from each other. And we're going to use the vertical angles quite a bit in proofs in geometry, and we're going to use vertical angles theorem. So this is setting you up for that. So it's going to be pretty crucial that you can recognize vertical angles. You're going to see it a lot this year. Complementary angles and supplementary angles. Complementary angles they are angles that sum to 90 degrees. Complementary angles are angles that sum up to 90 degrees. So they give us two examples of it. They can be either adjacent or non-adjacent. So they give us an example of adjacent angles that are complementary. So remember, a right angle is an angle that's 90 degrees. So we can tell that by this box. They're adjacent because they share a common ray, like we said before. We have angle 1, and we have angle 2. So angle 1 and angle 2 are complementary because when I add them up together, I'm going to get 90 degrees because I know that the big angle is 90 degrees. So they're adjacent complementary angles. Then we have some non-adjacent angles. So we have this guy, and we have this guy, and I know angle A and angle B, and I know that they are complementary because they give me the number of the degree, and they say that angle A is 47 degrees, and they give me that angle B is 43 degrees, and 47 plus 43 is 90. So since they sum up to 90, they're also complementary. So complementary angles, angles that when I add them up, they add up to 90 degrees. Then we have supplementary angles. And supplementary, I think there's two P's in supplementary. angles that sum up to 180 degrees or a straight line. 180 degrees or a straight line. And they're called supplements. Each complementary angles are called complement. Supplementary angles are called supplements. So again, if we're dealing with supplementary angles and they're adjacent, they're always going to form a straight line. They're always going to form a straight line. Always, 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 always going to form a straight line, and they're going to be adjacent. So these are examples of supplementary adjacent angles, because 180 is a straight line. And then an example of non-adjacent supplementary angles. That's weird. So we have one angle that's 137 degrees, and another angle that's going to be 143 degrees. So we look a little bit like this. Call that angle C and angle D. Now these would be examples of non-adjacent supplementary angles, because when I add them up, they add up to 180 degrees. And each angle, they're called supplements if they're add up to 180, and they're called complements if they add up to 90. All right, identifying angle pairs. So let's go through each example. So in part A, example A, we have angle BFD and angle CFD, and they are adjacent. So let's write BFD. Boom, boom, boom. So this is B, this is F, and this is D. And they ask me if they are adjacent angles. And this is actually where the whole common interior points come to play, but you're not going to really need to know this. But they ask me if they're adjacent angles, and the answer is no, they're not adjacent. So we said that for something to be an adjacent angle, there's three conditions. Common vertex, common vertex, common side, and the third part is they don't share any common points. Those are the three conditions. Okay, so in the case of BFD, so BFD is the big angle, and an angle, what's the other one? CFD. That's this guy. So when I look at it, here is angle C, angle F, and angle D in red. So that's the one angle. And the overall angle is angle BFD. Do they share a common side? They do. BFFD is something that they share. CFD and BFD both share FD ray FD. That's a common side that they share. Do they have a common vertex? Yes, they do have a common vertex. So they satisfy condition 1, they satisfy condition 2. The third condition is sharing common points. So angle BFD is this whole entire angle here. The whole entire angle here is BFD, right? Then angle CFD is all of this stuff in terms of interior points is over here, right? So if you notice, CFD and BFD have a common interior points right in here. They have common interior points. All of these guys would be considered they overlap, right? So they have common interior points. Common interior points. So since they have common interior points, they have points in the interior that they share. We say that this is non-adjacent. Non-adjacent. So these are non-adjacent angles. Okay. Example number 2, they asked me if these guys are vertical angles. So I have a ray here. And they want me to know if they are common. Well, not common. I want to know if they're vertical angles. Okay, so short answer is they are not. So not vertical. Not vertical angles. And the reason why they're not vertical angles is because they have to, for something to be vertical, we have to have a pair of opposite rays. A pair of opposite rays. Well, if we look at AD, these guys are opposite rays, right? They share a common vertex, and they go in opposite directions. If we look at BF, it goes in that direction, right? If it was to have an opposite ray, it would continue to go in the opposite direction, and that would have been its opposite ray, but it's not there. It's opposite. The other ray is this guy over here, and that's not opposite. It bends. It doesn't go straight through. So since it's not an opposite ray, we can't call this vertical angles. So AD, they go in opposite directions and share a common vertex. BE does not. B stops at F and then it turns at E. It had to keep going straight and keep going down in order for it to have been vertical angles. So no, they're not vertical angles because these are not opposite rays. BF and FE are not opposite rays. Therefore, they're not vertical. Jesus. All right. Complementary. So they give me this scenario. Oh, what the heck? They give me this scenario. these. That wasn't good. I have an A here, F here. Oops, that's not an F. I have a B here. I have a C here, and I have an E over here. I'm told that AFE is 62 degrees and BFC is 28 degrees. So BFC is 28 degrees and CFE, or is that A? AFE is 62 degrees, and they want to know if they're complementary. And the answer is yes, they are complementary. CFE, complementary angles. And they're complementary angles because when I add the angles, the measure of angle AFE plus the measure angle BFC, AFE is 62 degrees plus BFC, which is 28 degrees. That equals 90. So they're complements. So since they equal 90 degrees, I can say that they are complementary angles. Okay, so got it. Number one, they want me to know if AFE Alright, they want me to use this diagram up here. So they want to know if AFE and CDF are vertical angles. Alright, so this might be hard for you guys to see at first. So we have an angle here. We have a common point at F. And we have it going this way and this way. This is E. This is C. This is A. And this is D. And then we also have this guy coming up here. And this is B. We're told that this is 28 degrees. We're told this is 62 degrees. We're told this is 118 degrees. Okay, they want me to know if angle AFD, so it's this guy here, and angle BCD are vertical angles. No, wait. I think that's not what they asked me. Okay, they want to know if angle AFE and CFD. So they want to know if this angle, and they want to know if this angle are vertical angles. And the answer is yes. So for A, angle AFE and CFD are vertical. And they're vertical because they have a pair of opposite rays. So let's look at A and D, right? A and D goes in opposite directions, right? They're opposite rays. And so FD and FA go in opposite directions, and then FC and FE also go in opposite directions. They form the crisscross or they form the X, and therefore they are vertical angles. They want to know if BFC and DFE are supplementary. So BFC and DFE. Okay. So in order for them to be supplementary, they have to be equal to 180. Well, let's see if that's true. BFC is 28 degrees. And DFC is 118. And does that equal 180? Well, let's find out. 28 plus 18. That's what? 146. Guess what? That doesn't equal 180. So nope. They're not complementary. Right, comp. Not complementary. Alright. So then C, we want to know if BFD and AFB are adjacent. So here is BFD. So BFD is this guy. And then AFB is this guy. And by looking at that, I would say absolutely. Angle BFD and angle AFD B are adjacent. Why are they adjacent? They share a common side, BF. They share this common vertex at F, and then they don't have any common interior points. They are adjacent angles. Okay. All right, let's see more examples. Let's go down here. All right. So we have this thing, and they want to know what we can conclude and what we can't conclude, and things of that nature. Okay, so we have two segments. We have segment TV, and we have segment PQ, and they intersect each other at point W. And they want to know if I can make certain conclusions. The first conclusion is, can I say that TW, segment TW is congruent to segment WV? So TW is right here in the top, and WV is down here. Can I say this? Yes. And I can say this because of the markings. I'm told with the markings. So yes, because of the markings. They both have one tick, which means that they're congruent to each other. So I can conclude that. I can say that they're congruent. Can I say that PW, segment PW, is congruent to segment WQ? And the answer to that is absolutely not. So TW and VW had that marking. PW and WQ does not. So I don't have any markings to tell me that they're congruent. So I don't have enough information. Alright, so there are no markings. That tells me that they are congruent. They might be the congruent. It's possible, but I don't have. But it doesn't. I don't have any information from the picture itself to tell me that they are. C is angle TWQ a right angle? I'm going to say no. I don't have enough information. So no, not enough information. I don't have anything that tells me that it's 90 degrees. So if we look at angle TWQ, if I had this marking right here, then I'm like, okay, I have enough information to tell me that it's 90, but it doesn't have that marking. Or if it said 90 degrees, then I would have enough information to say, okay, it's a right angle. But since I didn't have any of those things, I don't have enough information to say that it's 90 degrees. So I can't say that it's 90. It could be. It's possible. Absolutely possible. However, I don't have. It doesn't give me any information, so I can't make that conclusion. D. Does angle TV, I mean not angle, segment TV bisect PQ? And the answer to that is I have to say no. So what does bisect means? It means to cut in half. So they're telling me that TV is cutting PQ in half, bisecting PQ. And again, I don't have enough information. So I don't have any markings. I don't have enough information. If TV did cut PQ in half, I would have markings like that that would tell me, oh, they're the same, so it's been cut in half, it's bisected. But since I don't have that, then I don't have enough information. It's not there. I don't have enough information to say that it is, so I have to say no, I don't have enough information. Okay. Linear pair. So linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So linear pair you guys will be seeing linear pairs a lot this year. They are adjacent angles their non-common sides are opposite rays. And they form a straight angle. And that's the key one. Linear pairs are always going to form a straight angle, and a straight angle means that it equals up to 180 degrees. They will always be adjacent, which means that they're going to share a common side, and that common side is always the guy in the middle, so they're going to share that. So they're going to be adjacent. They're going to form a straight line. So the non-common sides, the side that they don't share this guy, and they don't share this guy. So these are the non-common sides. Non-common side. Right? And then this would be the common side. This is the side that they share. So the non-common sides will form the straight line. The common side will always be in the middle. These are adjacent angles and they form a straight line. These are a linear pair. So knowing that they are supplementary, or they form a up to 180, we can do some math with it. So it says, how can you check the results in problem 3? I don't care about that. So they tell me for part B, ABD and BDC are a linear pair. And they say, okay, so first thing they give me, angle ABD and angle BDC are a linear pair. I'm told that the measure of DB, that makes more sense. ADB is equal to 3x plus 14, and I'm told the measure of BDC is equal to 5x minus 2. So they want to know the measure of the angles. Since I know that they're supplementary, I know that angle ADB plus angle BDC equal 180 degrees because they're linear pairs. So then I can substitute and I can say 3x plus 14 plus 5x minus 2 equals 180. I'm substituting using the segment addition postulate, which is also, this is I think the linear pair postulate, and it would be angle addition postulate. So this is the linear pair postulate. Okay, 5x plus 3x equals 8x. 14 and minus 2 is 12. Subtract 12 from both sides. 8x equals 168. And I get that x equals 21. So to find the angles, angle ADB equals 3 times 21 plus 14, which equals 77 degrees. So if they're supplementary, the other angle should be 103. And angle BDC equals 5 times 21 minus 2. And indeed it is 103 degrees. And then when I add 103 plus a 77, I should get 180, which I do. So these guys are correct. So this is 77. This is 103. Okay. Linear pairs, adjacent angles that form 180 degree. A linear pair postulate just says that when I add linear pairs, they always sum up to 180. They're supplementary. All right, last thing, angle bisector. Angle bisector. So I have an angle. I have an angle, and I have this other ray such that it cuts the angle completely in half. So this guy, not to scale, and this guy are the same. So angle 1 and angle 2. So since I know it cuts it in half, I can say that angle 1 is congruent to angle 2, or I can say that angle 1 is equal to angle 2. Okay? As this is a angle bisector. This ray is cutting this bigger angle, the black angle, completely in half, where the two small angles will always be congruent to each other or equal to each other. Okay. So for got it number 4, they tell me that angle KM bisects JKL. So I have this angle. JKL. There's my J. Here's my K. Here's my L. I have this other ray. Ray M. And ray M is cutting JKL completely in half, which means that this guy and this guy are congruent. They're the same. They're equal to each other. So they tell me that JKL, the big angle, actually let's do this. Since I know that they're completely in half, cut in half, I can say that angle JKM plus angle MKL is equal to the bigger angle, angle JKL. I can also say that angle JKM is equal to angle MKL. These angles are the same. Absolutely the same. Okay. They said that the big angle is JKL is 72 degrees. They want to know what the small angle is. Alright, so if these two guys are the same, instead of calling them JKL and MKL, I'm just going to call them X. X plus X. They say that JKL is equal to 72 degrees. So I can say X plus X, because they're the same, is equal to 72. Combine like terms. And I got 2x is equal to 72 degrees. I divide by 2, and I can say that x is equal to 36 degrees. Well, since they're the same, JKM and MKL are the same, I can say that angle JKM is equal to 36 degrees. The reason why I called them X is because it's easier to solve for a variable and they're the same as opposed to solving from with different letter angles. Okay. Alright, well that's this section. I hope you have a great rest of your